Hi everyone. I hope you all are doing good and good evening to all of you. So in my today's session, I'm going to cover a low-level design or a solid principle called open-close principle. Okay. So let's start with quickly. So what is it? The open close principle states that the classes should be open for extension but closed for the modification. Okay. So when you create a class, what this principle states that whenever you want to introduce new feature to that class, you should not modify that class itself. Instead, you should extend it and create new features or new functionalities to that class. Okay. Now, as the class is closed, it may be compiled, stored in a library, and may be used by a client classes. But it is also open for us since any new class may use it as a parent by adding a new features. Okay, so basically you are not disturbing your clients which are already making use of these classes. When a descendant class is defined, there is no need to change the original class or to disturb its clients. Breaking open close principle also breaks single responsibility principle. As already explained in my previous video, single responsibility says that your class's functionality should be narrowed with the single functionality of your application. Okay, and what happens is this open closed principle is directly connected with single responsibility principle. The moment you start adding additional features or the features which are not related to the functionality or responsibility of that class, basically you are breaking the SRP as well as open close principle. Okay, thus they say that breaking open close principle also breaks single responsibility principle. Okay, so uh, let's move on. So what are we achieving with the open close principle? First of all, avoiding the redundant regression testing cycles. Okay, because you are damn sure that whatever new features you are going to introduce to your product is basically in terms of new classes by extending the existing classes. Thus there is no need to test the existing functionalities which are already working and they are fine. Okay, and as I said, testing teams are not required to do regression testing for the whole feature itself, as new functionalities are added by extending the parent abstract classes. Okay, so this basically reduces the additional effort required of regression testing, and it also reduces the cost involved with that. And at enterprise level software development, usually the management doesn't like this kind of frequent regression tests or testing everything from scratch whenever a new feature is introduced. Okay, so that's what we are achieving here. Cohesive libraries, that is, software units are easy to comprehend and are more reusable. A class that does only one thing and does it well is more likely to provide value in different contexts than a class that aggregates many unrelated behaviors. Okay, so we will end up with creating a cohesive libraries, so we don't have any tight coupling here basically. Okay, and advantage of such libraries is that even if a client is making use of such libraries, okay, you are basically introducing new features by extending the existing classes, and clients are rest assured that they are not required to do any changes in their existing class references they are making. Okay, product maintenance, once we know that all our functionalities are properly extended in their respective derived classes, it becomes very easy to do further enhancements to the product. We basically avoiding the problem of spaghetti code. So basically we are not, if there is some new requirement, okay, if there is a new requirement is coming and if we don't use open close principle, then usually we will be putting some conditions like if for this scenario do this, if for that scenario do that. So basically you are avoiding these conditional functionalities. Okay, that's why it becomes easy for the product maintenance as well as the product source code also, and we avoid the problem of spaghetti code. Extensibility and scaling, OCP allows extensibility to the granular level of class, thus not touching the unintended parts of the product. This level of extensibility makes the scaling of the enterprise product much easier because you are adding new features in terms of new classes, and whenever you add features in terms of new classes, your unit testing also becomes much easier because you are not going to disturb any of the existing unit tests which you have implemented for the previous features. Whatever unit tests you introduce, that is for the new classes that you are implementing. Thus unit testing is much faster and we can achieve good quality. Okay, so let's go with the example now. So now I have a class called simple interest service. It calculates simple interest for us. Okay. So when I have not applied OCP, okay, this class looks something like this. So I have came up with a requirement where I have to write a service which calculates simple interest for me. Okay, so what it is doing for me, okay, it is taking principal amount time period from the constructor and it is setting it to the internal members. Okay, and then there is one public contract or a public method called calculate. So this calculate method calculates simple interest for me. Okay, at the first glance it seems quite obvious, it is correct. Okay, and it should serve my purpose. So if I go to my main program, see, I have written I have instantiated a simple interest service class object and I am calculating. For example, I have come up with the first requirement of home loan. Okay, now the simple interest for home loan is simply I'm invoking this method. So if I run this, there should be no issues. It should calculate the simple interest for me. Let me show that. So as you can see, the simple interest for home loan is 2000 for the given input. Works very well, no issues. But now I come up with a new requirement. Okay, let me explain that. Okay, till now I was supporting only a home loan, but now I have came up with a requirement from management that I have to support. Okay, I'm a bank person, basically I have a bank and I have came up with a requirement that I have to support a vehicle loan also. Okay, or I have to support a jewelry loan also. Now how I can, at the first glance, if I want to implement both the vehicle loan and jewelry loan requirements, because for them the interest rate is quite different. Okay, so at the first glance, if I want to introduce that, what I would think, the brute force technique basically. Okay, what I'm going to do is I'm going to introduce a parameter to this calculate method called loan type. Okay, what I will do is I will introduce a loan type parameter here, and based on that loan type, I will try to calculate the interest. Let me show that quickly. So for the sake of time, I have quickly implemented, as I already explained. Suppose I have came up with a requirement of vehicle loan now. So what I have to do is basically now I have to, that's a brute. The first thing which comes to most of the developers mind is let's introduce a loan type property. Okay, or loan type member to your class, receive it in the constructor. Okay, and while calculating the simple interest, check for the loan type. If it is home loan, apply a rate of interest of 10%, and if it's a vehicle loan, apply the rate of interest of 5%. Okay, if I run this program, guys, the output or the result will be same basically. Okay, if you see, yes, I'm achieving the same. The home loan, for the home loan the interest is 2000, for vehicle loan it's 1000. But but I have violated the open close principle here. Let me go through that quickly. What open close principle says is basically a class should be open for extension, but it should be closed for modification. But what I did, this was my service class which I used to calculate the simple interest. And what I did, the moment I got a requirement for a vehicle type, okay, the moment I got a requirement for the loan type of vehicle, I was required to introduce one annum. Okay, I was required to introduce one more property here into my class. And also the most important thing which concerns me is I have to put if conditions now in my calculate method in order to calculate the simple interest. See, if loan type equal to home loan, do this. If if the loan type is equal to vehicle loan, do this with 5% rate of interest. Wrong. This is where I basically broke the open close principle. This is where I introduced a regression. If this class was being used by existing client, okay, I have made, first of all, what I did, I changed the constructor's signature itself. Now that client class or the client who was using this class, they have to change their code, or change, or even I need to provide a new build for them which supports a constructor having three parameters. Okay, so I basically made my client to change their build in order to have this new update or this new change. This is not at all desirable for your clients or the end users. Okay, you are disturbing them. Okay, this is not at all acceptable. And also I created a regression, and most of my existing unit tests which I had written to ensure quality of simple interest service will start breaking now. Why? Because now this method is doing two things. One, okay, based on the loan type, it is calculating simple interest for home loan and vehicle loan. Again, I need to introduce the coverage for the additional condition I have put here, which is wrong. I am introducing regression. So how can we solve this problem? This problem, the problem of breaking open close principle, can be solved by doing the following changes. So let me quickly do that for you people and demonstrate it. Okay, so okay, so now what I have done is basically, first of all, now I don't need this loan type enumeration. I can easily skip this. Okay, now by applying open closed principle, what I have to do is I have made my simple interest service a abstract class, basically a parent which can be extended. And what I have done is, now this calculate method has been abstracted out. Now it is up to the derived class who implements or who overrides this method will provide its own implementation. Okay, so this base class is not going to decide it now. Okay, as per the OCP, a class is open for extension. So I am satisfying this first condition. Now this class is open for extension. Okay, but now it is closed for modification. Okay, now if I want to introduce new features, like for example, okay, home loan is a new requirement and vehicle loan is also a new requirement. And now if I want to implement that, what I have to do, I have to create a new class which inherits my simple interest service abstract class now. And then it has to provide an implementation for the calculate method that I had provided. See the signature, public override decimal calculate. Now for the home loan, see, without checking any condition, if type is equal to this, nothing is required. Simply put the interest rate of 10 over here. Okay, the rate of interest 10 here and calculate the simple interest. Same, go to the vehicle loan type, simply create one clause. Okay, and provide a implementation for the abstract calculate method supplied by this base class. Okay, and in this case I will put the rate of interest as 5%. And whenever you receive the principal amount and time period, simply call the basis constructor or the base class constructor and pass the values. That's it guys. Now look at the code, how clean it is. Okay, now I am not at all breaking the open close principle. My class is open for extension now. My simple interest service class is open for extension, but now it is closed for modification. I don't want to make any changes over here. Now, whenever I want to introduce new features, they will come in terms of new classes. Okay, isn't that great? Isn't that clean? Right? So, if I run the program, is there any change? No, there will be no change. Absolutely. Okay, so for example, if for my first requirement I had implemented home loan simple interest calculation service class. Okay, when first time I received the requirement, I had only home loan interest calculation, I had this class only. But when second time I received a requirement of vehicle loan type also, see, I didn't made any change to this class or my base abstract class. Instead, I inherited from my base class and provided a new implementation. This way I'm not at all disturbing my client who was making use of the earlier home loan simple interest calculation service class. He can continue with that implementation. I'm not breaking his code. Simply, I'm providing a new functionality that he can use. And if I run the program, there is no difference at all. Still, I will get the same output. So let me show that quickly. So can you see the output? Yes, the simple interest for home loan is still 2000 and simple interest for vehicle loan is 1000. So I hope you people understood the significance of applying open close principle. Okay, it ensures the single responsibility principle, as well as it also provides the flexibility of open close principle features. Okay, so I hope this is pretty much clear for you people. So I hope you people understood the significance of open close principle now. Okay. So we are not disturbing our end users or end client who is already making use of our library. Okay. See, the base class or the abstract base class which is meant for extension, using that classes object reference variable, I am able to construct my extended classes. Can you see here? Okay, as I'm not doing any changes to my base classes methods signature, that's why I'm able to construct these objects using the base classes object reference, and I'm able to invoke the calculate method, and it will calculate same results as it was calculating before for home loan as well as vehicle loan. I hope you understood the concept here, and please apply in your design. uh, I think that's it from open close principle. Thank you for listening. Have a nice day.